Hi, I'm Hideaki Kuzuoka. Most of the current groupware supports two-dimensional work, such as drawing and writing. To support collaboration within an industrial framework or general communication, however, groupware should support collaboration in a three-dimensional environment. We define collaboration in a three-dimensional environment as spatial workspace collaboration. As an example of spatial workspace collaboration, we're trying to support remote instruction on how to operate machinery. When this kind of communication is undertaken face-to-face, an instructor changes places to look at very frequently and uses finger pointing many times. Also, as Ishii and Kobayashi said, gaze awareness is playing an important role for smooth communication. When an instruction should be given remotely, however, it is hard to communicate because an instructor cannot look around, an instructor cannot point at an object, and gaze awareness is not supported. For example, many of us know that it is very difficult to explain over the telephone how to operate a machinery. Even with a video conferencing system, it is hard to support this kind of communication. For example, often objects are out of the field of view of a camera, and it is hard to specify remote position. Therefore, in order to support spatial workspace collaboration, we think that a system should support ability to look around a remote site, ability of remote pointing, and gaze awareness. According to these considerations, we have been developing the video communication system named the gesturecam system. The gesturecam is an actuator with 3 degrees of freedom of movement. A small finger-sized camera and a laser pointer are mounted on the actuator. The gesturecam is controlled remotely by an instructor, so an instructor can look around a remote site freely. In this case, the instructor is controlling the gesturecam by a master actuator. The laser pointer is used to point at a certain object in the same way that a finger points. An instructor can turn on and off the laser by a simple operation. Now, please see the demonstration session between an instructor and an operator. This is the instructor's site. The instructor can look around the operator's site by manipulating the master actuator. This is the operator's site. The gesturecam becomes a surrogate instructor, so an operator can get instructions by the gesturecam. Because the gesturecam moves in front of an operator and is highly visible, an operator can involuntarily sense its motion with their peripheral vision. Therefore, it is expected that the gesturecam supports remote gaze awareness, and operators can predict that an instructor may point inside his or her field of view. In this way, the awareness to the camera helps to define the area which is being pointed at. Privacy is another important issue for video communication systems. Using the gesturecam, a user can notice that no one is looking at him when it is sleeping, and it wakes up, he can naturally start conversation. We have been conducting many experiments using the gesturecam. This video shows one of those experiments. In this case, the instructor in Japan gave instructions to the operators in Hawaii on how to connect 2 personal computers. This is the operator's site in Hawaii.
This connector is this port.
I think it's just
Second port.
second part. Hi.
And this is the instructor's site in Japan.
The instructions are only for you. こんにちは。
はい。
受けてる。
Oh, konnichiwa. Is that what he said? Hi.
Through the experiments, we have noticed that an user interface to control the gesturecam affects the communication. Therefore, we're developing some other user interfaces for an instructor to control the gesturecam more intuitively, and comparing their advantages and disadvantages. In this case, a small display is mounted on the master actuator. It is expected that the instructor feels that he is looking around the remote site through a small window. This interface is using a touch-sensitive display. An instructor can change the image by dragging a finger across the display. This interface is using a gyro sensor. We place the sensor inside the stuffed animal so that an instructor can easily imagine the direction of the remote camera. Now, I have showed you our ongoing research to support spatial workspace collaboration. By studying the actual use of the gesturecam system, we hope to better understand how people interact in a real three-dimensional world, and how technology can support spatial workspace collaboration.